matrix algebra and how we can multiply the two matrices, how we can find the transpose of the matrix. So in these things, how we can find the inverse of the matrix. So these things we will discuss today. So let us restart. So for example, first of all, we are going to start that if we have the two matrices, we have two matrices, a matrix A and the matrix B, and for example, the matrix A will be n cross n matrices. Then the sum, if we want to add the two matrices and A and B, and it is denoted by A plus B, the matrix obtained by adding the corresponding elements of A and B. So, for example, these are the two matrices. The matrix A will be 2 by 3 matrix, 2 by 3 matrix, and the matrix B will also be 2 by 3 matrix, 2 cross 3 matrix. Now, if you are going to add the two matrices, so you have to add each and every element with the corresponding elements. So for example, so first of all, we are going to add 1 plus minus 3. So when you are going to add these two things, you will get minus 2. So similarly, on the next time, you will add minus 2 with 0. So you will get a minus 2. Similarly, if you are going to add 2 with 4, so you will get 6. Similarly, and then if you are going to add 0 with the 2, you are getting 2, and minus 1 adding with 1, you are getting 0, and 3 adding with minus 4, so you are getting minus 1 here. So these are called the addition of the matrices. So one by one it's showing here. So similarly, there are several properties of the matrices. So as I told you that the matrix property hold the commutative law, associative law, distributive law, and there are various laws are hold. So the commutative law says that if we have the two matrices, a matrix A, and there is another matrix, there is another matrix that is called the B matrix. So if we are going to add a matrix A with the matrix B, then it will be equivalent to matrix B and matrix A. So it is called the commutative law. Similarly, the matrix addition is also associative. So associative means if we have a three matrix A, B, and C, if we are going to add these three matrices A plus B plus C, then it will be equivalent to, if we are going to first add A plus B, then after we are going to add the C. So these two things are equivalent. So it means that the matrix addition is also the associative law holds in the matrix addition. So next is scalar multiplication of the matrix. It says that when we are going to multiply any constant with the matrix, let us assume that we have a matrix n cross n matrix, and there is a S is a scalar, or then we let Ka denotes the matrix obtained by multiplying every element of A by K. So this procedure is called the scalar multiplication. So let us take an example. It says that we have a matrix A, and we are going to multiply A with a constant 3. So if you are going to multiply 3 with A, then every element you have to multiply with this element. So 3 multiplied by 1, 3 multiplied by minus 2, 3 multiplied by 2, 3 multiplied by 0, 3 multiplied by minus 1, 3 multiplied by 3. It means every element we have to multiply with that element. That is called the scalar multiplication. So after you are going to multiply, you will get this matrix. So it is called the scalar multiplication of the matrix. So whenever we are going to multiply any constant, any scalar, it means it will multiply by the whole matrix. So there are several properties of the scalar multiplication. So this is the property number one. It says that property number one says that if we have a kh, if we have any scalar k and if there is a matrix ha, then we can write the scalar outside kh and there is a matrix is outside. So this is the property number one. Similarly, if we have a constants like k plus h and there is a matrix A, and so we can write ka and plus ha. Similarly, this is property number two of the scalar. Similarly, property number three of the scalar, it says that if we have a scalar and one scalar and there are two matrices A and B, there are two matrices are there. So when you are going to multiply these scalar to these matrices, so every scalar will multiply by every matrices. So for this scalar multiply by this matrix and this scalar multiply by this matrix. So these are the properties of the scalar multiplication of the matrices. So these are the basic rules of the matrices. Hopefully all of you understand clearly. So the next thing is there is a matrix is called a zero matrix and it is denoted by zero, yani capital zero and curly zero, or there is a little bit tilt in that zero, that is called a zero matrix. So zero matrix is denoted by O, and the property of this zero matrix is every element in this matrix will be zero. This is the property of the zero matrix. So here it is a zero. This is a 2 by 2 matrix, and here we can write it is a 2 by 2 2 cross 2 matrix. So we can write a 2 by 2 matrix will be 0 0 matrix. Similarly, there is another matrix like a matrix will be zero matrix. It is a 1 cross 3, yani it has one row and there are 3 columns are there. So this matrix is called a zero matrix. So similarly, there are several properties of the zero matrices. So property number one, it says that when you are going to add a zero matrix with any matrix, this is any matrix A, and you are going to add a zero matrix with that matrix, you will get the same matrix. So don't confuse this. This is not a zero. It is a zero matrix. It is like this. It may be like this. It is like this. Any 0 0 0. So 0. So when we are going to, and it is A is also a matrix like a matrix like 1 2 3 and 4, like this. It has a matrix A, and when you are going to add this matrix with a zero matrix, you will get the same matrix, that is A. So it is the first property of the zero matrix. The second property of the zero matrix is when you are going to add the negative of the matrix. For example, if you have a matrix A and if you are going to add the negative of that matrix, so you will get a zero matrix. For example, if we have a matrix A, as I told you, yeah, like 1 2 and 3 4, this is a matrix A, and if you are going to add the negative of this matrix, like if you are going to add the negative of this matrix like -1 -2 and -3 and -4, so if you are going to add these two matrices, you will get a zero matrix, that will be a 0 0 and 0 and 0. So you will get a zero matrix. So this is the property number two. And similarly, the property number 3 says that if you are going to multiply a zero matrix with any matrix, you will get the zero matrix. So these are the three properties of the zero matrices. Now let's proceed. So there's multiplication of a matrices. If we are multiplication of the matrices means the multiplication of the matrices is easier shown that the put into words. You multiply the rows of the first matrix with the column of the second, adding produce. So here we are showing with how we can multiply the matrices and how we get this result. So hopefully I will share my desktop on, then after you can watch clearly. Here it is not showing clearly. So where is so this is it says that how we can multiply the two matrices. There are two matrices are given, and we have to multiply the two matrices A with B. So we see how we can multiply these two matrices. So first of all, we will take the first row and we will take the first column. So it is written as first we multiply across the first row and down the first column, adding product. We put the answer in the first row, the first column of the answer. So we see. So first it will take 3 multiplied by 2. So 3 to the 6. So I write here 3 multiplied by 2. Again it will take minus 2 multiplied by minus 1. So I write here minus 2 multiplied by minus 1. Similarly, and the next time we multiply by 1 multiplied by minus 3, that will be 5. So I write our first element will be 5. Similarly, we will write here our first element will be 5. So I write here our first element. So next time, now we multiply across the first row, and we multiply across the first row and down to the second column, and we will put the answer in the first row, second column. So we see again. We multiply the first element to the second column first element, and right here 3 4s. And second time I will take the second element of the first row and the second element of the second column. So that's we multiply minus 2 multiplied by 3. So I write here, and next I will take the third element of the first row and the third element of the second column. So I will multiply 1 multiplied by 1, that will be is equal to 7. So it is 7 is the second element of the matrices in the first row. So I write 7 on that place. So now our first row is complete. Now we will take the second column, second row and first column. I will repeat this same steps again. So now we multiply across the second row and down the first column, and we will put the answer in the second row, first column. So we see 0 multiplied by 2, we will get a 0. So 0 multiplied by 2, our first element, plus we multiply the second element of the second row and the second element of the first column. So that is 4 multiplied by minus 1. So I write here 4 multiplied by minus 1. Now again I will take the third element of the second row and the third element of the first column. So I will multiply by -1 and -3. So I write here -1 and -3. So just adding all them, we will get -1. So I write -1 in place of the second row first column, and I write -1 in this place. So that will be -1 here. Now one element is left. So I will multiply the second row with the second column, and the first element of the second row and the first element of the second column, that is 0 multiplied by 4, that will be equal to, so I multiply 0 multiplied by 4, so I write here 0 multiplied by 4, so that's why I write here. Again I will multiply 4 multiplied by 3, that will be is equal to, right, I write here. Now lastly I will multiply by the third element of the second row and the third element of the second column, that will be -1 multiplied by 1. So I write here, and adding all them we will get 11. So 11, I put this 11 on the main matrix. So that is called the multiplication of the matrices. So hopefully all of you understand how we can multiply the two matrices. So it's a very easy process. यानी कि first row first column, and first row second column, then second row first column, second row second column. This is the steps we have to uh, apply. Notice that the size of A and B and the size of the product AB. So if you observe that both the sizes are same, and whatever the size of A is and whatever the size of B, so it will, you can, and whatever the size of AB, so the size of A will be 2 and 3, and the size of B will be 3 and 2. So the size of the matrix AB will be 2. So it is the rule of the product. So to multiply the matrix A and B, look at their dimensions. So as I told you last time, only when we can multiply the two matrices, when first matrix will be M cross N, and another matrix must be N cross P. यानी कि and N are the same. If these N are not same, then we cannot multiply the two matrices. यानी first matrix will be 2 by 3, then second matrix must be 3 by 2 or 3 by whatever. So only when we can multiply. यानी if first matrix will be 4 by 5, then second matrix must be 5 by whatever, 5 by 1, 5 by 2, 5 by 3, 5 by 4, whatever it is that. So meaning is that and N and N, yani whatever the column and whatever the row, so which we multiply are the same. So these two things are same, then only we can multiply the two matrices. So must be same, it is written here. Only when these two are same, then we say that we can only multiply the two matrices. The size of the product, and whatever the size, M and P are declare the size of the matrix, where after you multiply the matrix, that will become the size of the matrix. So if the number of columns of A does not equal to the number of rows of B, then the product of AB as undefined. Yani meaning is that we cannot multiply the two matrices if the length of the column is not equal to the number of rows, then we cannot multiply. Yani N and N are same, only then we can multiply. So now let's look the product of BA. What happened? So there are two, as usual. There are before two slides I show you how we multiply A and B. Now let's look what happens if we multiply B cross A, yani just reverse. B first we take B and then we take A. So first of all, tell me, can we multiply these two matrices? So our answer is the number of rows are 1, 2, 3. There are the number of rows of B are 3 rows, and number of columns of B are 2. So, and the number of rows of A are 2 and number of columns are 3. So yes, we can multiply two matrices B and A because of the 2 and 2 are the same. So we can multiply the two matrices. So we start to multiply. So yes, we can multiply because of the size, because of here is a 2 and here is a 2, both there is a 2, so only we can multiply. And what is the size of the matrix? The size of the matrix, it will be 3. So whatever the outside part, that is called the size of the matrices. So the size of the matrix is 3. So we start our, we take first row and first column. So 2 multiplied by 3 and 4 multiplied by 0. So we will get a 6. So we take 6, our first element of the new matrices. So we write 6 as the first element of the new matrices. Okay. So now we will take the first row and the second column. So across the first row and second column. So in this way we can multiply 2 multiplied by minus 2 and 4 multiplied by 4. So that will be is equal to 12. So I write this 12 in that place. That will be is equal to 12 here. Now our next step is we will multiply first row of B and the last column, third column of A. So when you multiply these two, that will be is equal to 2 multiplied by 1 and 4 multiplied by minus 1. So that will be is equal to minus 2. So I write minus 2 is the last element of first row. So our first row is complete. Now we are going to move to the second row of the matrix B. So we are going to move the second row of the matrix B. That will be is equal to let's we read first element of row 2 with multiply by first element of column 1, that is minus 1 multiplied by 3 and 3 multiplied by 0, that will be is equal to minus 3. So I write minus 3 will be the first element of the second row. So I write minus 3 here. Now again I will take the second row and second column. So I will consider the second row and second column. So I will multiply minus 1 multiplied by minus 2 and 3 multiplied by 4, yani 3 multiplied by 4. So that will be is equal to 14. So I write 14 here. That will be is equal to 14. I write. Now lastly I will multiply by second row and the third column, that is minus 1 multiplied by 1 and 3 multiplied by minus 1. So that will be is equal to minus 4. So I write minus 4 here. So that will be is equal to minus 4 here. So next thing is, next we will take the third row and the first column. So that is minus 3 multiplied by 3 and 1 multiplied by 0. So when we multiply it, we will get a minus 9. Similarly, third row and second column, minus 3 multiplied by minus 2 and 1 multiplied by 4, that will be is equal to 10. So I write 10 here, that will be is equal to 10. And similarly, lastly, I will take third row and the third column, that is -3 multiplied by 1 and 1 multiplied by -1. So that will be our last element, that is called the -4 here. So it is our complete matrix, that is a BA matrix. So can we notice that before 3 slides you show that I showed you the product of AB will be a 2 by 2 matrices, but here the product of BA will be 3 by 3 matrices, and there are totally different matrices. Meaning is that the product of AB does not is equal to the product of BA. So we conclude that AB does not is equal to BA. So it is completely different between the AB. It means that AB does not is equal to BA. So it is the rule of the matrices. But in normal algebra, if we are talking that 2 multiplied by 3 is equal to 3 multiplied by 2, it happens in normal algebra. 2 multiplied by 1 is equal to 1 multiplied by 2. But in matrices, it is not equal. And A multiplied by B does not is equal to B multiplied by A. So that's I show you here. So now AB does not is equal to BA. So now we proceed. There are some properties of the matrices multiplication. So the properties of multiplication, the properties are: it holds the commutative law, it holds the distributive law, and it holds the. So there are several laws are there. So the question is it possible that AB is equal to BA? So yes, in particular case it is possible that AB is equal to BA, but not in general. You cannot say in general that AB is equal to BA, but in a particular case it will be equal. So next thing is we will discuss what is the identity matrices. So the definition of the identity matrix is an n cross n matrix with 1 on the main diagonal and 0 is elsewhere is called the identity matrices. So for example, their matrices, this is the I3 identity matrix. If we observe that all the elements on the main diagonal, all the elements in the main diagonal are 0, all the elements in the main diagonal are 1, and rest of the elements are 0. So that is why we say that it is a identity matrices. So now what happened? The question is, what happens if we multiply any matrices with the identity matrices? So what happened? So the answer is we will get the same matrices. There is no any change. If we multiply any matrix to the identity matrix, we get the same matrix. So in normal algebra, it is also happens. If we are observing in normal algebra, if we multiply 2 into 1, we will get a 2. If we multiply by 3 into 1, we will get 3. If we multiply 4 into 1, we will get a 4. So similarly here also in matrix algebra, if we multiply any matrix with the identity matrix, we get the same matrices. So it is a if we multiply A into I, we will get A. There is no any difference. And what happened if I multiply identity matrix with any matrices? So the result is same. There is no any change. Any I into A or A into I, both are the same. So we will get the same result. So now this is a particular case. In this case, you can say that AB is equal to BA only in this particular case you can say, otherwise you cannot say like this. Okay, so if someone asks a question whether it is, can you say that AB is equal to BA, so you say that no, it is never equivalent, but in some particular case. So what is the particular case? The particular case is identity matrices. If you are going to multiply any matrix with the identity, then it will be AI is equal to IA. So that's a particular case. Multiplying a matrix by a identity gives the matrix back again. So can we find a matrix to multiply the first matrix to get the identity matrices? So what happen if I multiply? So we get the, how we can get this matrices. So this is the matrices, and what is that matrices? So the question is, if I multiply this matrix to add any matrix, we get the identity matrix. So what type of these matrices? So this matrices is called the inverse of the matrices. How we get this inverse? That's a long procedure, as I told you in my first class. So when you are multiply any matrix with its inverse, you will get the identity matrices. And A into A inverse is equal to I. So or you can say that A inverse into A, that is also equivalent to I. So let A be an n cross n matrix. If there exists a matrix B such that AB is equal to B is equal to I, then we call this matrix is the inverse of A, and it is denoted by A inverse. So if A has an inverse, we say that A is a non-singular. If A inverse does not exist, we say that A is singular. So whenever A inverse exists, then it must be a non-singular. So for example, there is a matrix A 1 3 minus 2 7. So you have to find, if you have to find the inverse of this matrix, so first of all you have to write the matrices like A slash I in this form. You have to write the matrices in this form. So A slash I. So left hand side will be your matrices, and the right hand side you have to write the identity matrices. So I will show you how we can find the inverse. So with the help of row operation. So here it is the identity matrices. Now I will apply the row operation again and again until we get the left hand side will be the unity, and whatever the matrix we obtain on the right side, that is called the inverse of the matrices. So we start the procedure. So our first aim is first element will be 1, so it is automatically 1. There is no need to apply any operation. So our next aim is I want to remove -2 here. So I will apply the row operation, R2 plus 2 times R1. So with the help of this row operation, it will become 0 in this place. Any first element in the second row will be 0. Similarly, our next aim is I want to remove minus sign from here, and then our aim is I want to remove 3 from here. So I will apply again the row operation to remove the minus sign. I will apply the row 2 multiplied by -1. So I multiply row 2 with -1. So that is why it will be equal to 1. So our last aim is I want to remove 3 from this place. So I will again apply the row operation R1 minus R2. So it will become 0. So we observe that our left hand side matrix will be unit matrix, and whatever the matrix on the right side, that is called the inverse of the matrix. So the matrix A is 1 3 minus 2 minus 7, and the inverse of the matrix is 7 3 minus 2 minus 1. This is the inverse of the matrix. So that is called the inverse. So what happened? Check this answer by multiplying. We should get the identity matrix if we found the inverse. So this is A and this is A inverse. So if you want to check your result whether it is correct or not, so if you just multiply A into A inverse, if you are going to multiply A into A inverse, you must get an identity matrix. If you are not getting an identity matrix, then it is sure that you are getting some mistake somewhere. There is a problem. So when we are going to multiply A into A inverse, we will get an identity matrices. So that's the rule of the inverse, to find the inverse of the matrices. So hopefully you understand clearly. The row from the row operation we can find the identity, we can find the inverse of the matrices. Now there is a second type rule, and in this type of rule it says that what happens if we have given the system of equations and you have to say that find the inverse of this, find the value of x and y with the A inverse. So till now we discuss, we are given a, till now we are given a 2 by 2 matrices, 3 by 2 3 matrices, and now here we have given a two system of linear equations, and the question is find the value of x and y with the help of A inverse. So first of all we will write the equation like Ax is equal to B. A means whatever the coefficient matrix is. So I write the coefficient matrix, and x means xy, and B means whatever the right side. Any right side will be 1 and 3. So let's it's equation number 1. Ax is equal to B. So A will be the coefficient matrices, x will be the variable matrices, and B will be the constant matrices. So we write separately the coefficient matrices, variable, and constant matrices. So the coefficient matrices will be 1 3, and the coefficient of x will be 1, the coefficient of y will be 3. Similarly the coefficient of 2 will be 5, x will be 2, coefficient of y will be like this, 5. So I write the coefficient matrix here. Similarly the variable, I write the variable matrices x and y, and that will be is equal to 1 and 3 will be that is the right hand side. So our aim is to find the inverse of the coefficient matrix, because of what we have to find the value of x and y, and x is equal to A inverse B. This is by the theorem. If we just take the A will be the left hand side, that will be x is equal to A inverse AB. So we have to find the value of A inverse. So let's see how we can find the value of A inverse. So to multiply that, so identity matrix, so we have to find x is equal to A inverse. So first of all we will find the value of A inverse, and after that we put the value of A inverse here, so that we get the value of x and y. So we see how we can find the A inverse. So as you know, there is the same procedure. So let us put this equation is 1, x is equal to A inverse B. This is equation number 1. So we have this equation. Just write the coefficient matrix. It is our coefficient matrix 1 3 2 5 is a coefficient matrix. Now apply the row operation again. First of all write the identity matrix A slash I. So I write the identity matrix, yani A slash I write in this form. So our first aim will be first element should be 1. So it's already first element, it's already 1. So there is no need to change anything. Now our next aim is I want to remove 2 from this. So when I remove 2 from this, so that will be is equal to I apply the row operation R2 minus 2 R1. So that will be is equal to 0. Our next aim is I want to remove minus sign from here. So I will apply minus 2R2. So when I apply minus 2R2, so that will be is equal to 1. And lastly, my aim is I want to remove 3 from this. So I will again apply the row operation. That will be is equal to R1 minus 3R2. With this help, I will get the identity matrices on the left side. That will be is equal to 1 0 0 1. That is the identity matrix on the left side. So our matrices will be identity on the left side. So what is the inverse of this matrices? So inverse will be -5, 3, 2, and -1 is the inverse. So we put this is the inverse. So A, B. So now we put the value of A inverse in equation number 1, as I told you now. So X is equal to A inverse B. It is equation number 1. So X is equal to A inverse B. A inverse B, yani A inverse, and B will be right hand, whatever, 1, 3. So when I multiply -1 multiplied by 1, 3 multiplied by 3, similarly 2 multiplied by 1, and -1 multiplied by 3, that will be is equal to 4 and -1. So the value of X and Y will be 4 and -1. So this is the X and this is the Y. This is the answer to the system of equations. So hopefully you understand clearly how we can multiply the two matrices, how we can multiply these things. So if you have any questions, then you can ask me. Okay. So as I told you, I upload these PowerPoint slides. Wait a minute. Please keep online. I will take the attendance. So as I told you, okay. As I told you, I create a folder, extra resources on the Blackboard. You can find that folder, and on that folder you can find these PowerPoint slides. You can download these PowerPoint slides over there. Okay. So okay, now we can go. Good night and have a nice day.
Recording stopped.